Hi there, this is just a quick video on a question which Corriday showed me at the very bit end of the lesson, like he always loves showing me a question right at the end of the lesson. But yeah, anyway, I just wanted to quickly talk about it, just in case it comes up. I don't think it will, but just in case. Quadratic with complex coefficients, how do you solve it? Well, quad formula will work, it really will. There's just one awkward bit in it. You've just got to basically do minus b. Like I've collected, obviously, the z squared, the z, and a number on the end, minus b plus or minus root of b squared minus 4ac over 2. Now, the one thing which is going to get tricky is a discriminant, because after you do it, you're going to get minus 5 plus 12i, yeah? And you can crank through the algebra and you'll see that. Now, you've got to square root that, and so it's like, oh, well, how does that work? Well, the best way to do it is just to let it equal a plus bi. Then you can say, okay, square out the a plus bi. So we're going to work out what a plus bi all squared is. The reason why I've got all the working done here is because I just worked it all the way through to the end and just made a sign error somewhere, so I couldn't demonstrate that it worked. But if you do that squared, you end up with this, and then you can equate coefficients. So minus 5 must be equal to the a squared minus b squared, and 12i must be equal to the 2abi. In other words, 12 is 2ab, in other words, 6 is ab, so 6 over a is b. You can plug that in. So minus 5 equals a squared minus 6 over 8 all squared. You get a disguised quadratic, so you end up with a quartic, but it's really a quadratic, and you get the following values. Now we know a is real, so I'm going to ignore that. So I get a squared minus 4 is 0, so a is plus or minus 2. In which case, and this is where I blundered before, b is going to be plus or minus 3. Yeah? Now all we've got to do is plug it back into the quad formula. We're going to get that. Now let me just correct some of my working down here because some of it's wrong now. Because I was just trying to show you that it did work basically at the end, because we should always be able to check something which we solve in maths. Like, that's the idea. Anything you solve in your exam, especially with a calculator, you should be able to check it quick. And you could certainly check this result with a calculator quick, although your calculator apparently won't help you solve quadratics with complex coefficients, but we can check it very easily. So I'm just plugging in now my plus positive 2 with b is positive 3, and I'm going to get I plus 3i is 4i divided by 2 is 2i, minus 6 plus 2 is minus 4 divided by 2 is minus 2. So that's supposed to be a root. Well, if we go back to our original equation, which is z squared plus z times 6 minus I plus 10 minus 6i, I think. Memory is failing me. Yeah, good. Okay, if we plug this into it, let's test it. Test z1. Let's see if it does equal 0, because this is supposed to equal 0. We've got 2i minus 2 all squared plus 2i minus 2 times 6 minus I. And I'm testing it really for my own benefit as much as yours. If you've already got the general gist of the video, good. You can obviously do something else. Minus 4i is minus 8i, and then you're going to get a plus 4. Oh, they're going to cancel because that's minus 4 plus 4. And then we're going to get 12i minus 12 minus 2i squared, well, that's plus 2, and then minus 2i plus 10 minus 6i. And then hopefully 12i minus 2i, well, minus 8i plus 12i is 4i. This doesn't look like it's working again. Don't tell me I've fumbled it again. Minus 4i minus 4 is minus 8i. We've got a 12i there. That's good. So that's 4i. And then that's going to take me down to... Now, did I get the sign wrong on this at the end? Look, that's a plus 2i. There we go. Too many mistakes after work. I'm too tired. So minus 8i plus 12i is 4i. 6i minus 6i, there we go. I'm not like my excellent students in my class, they never make errors. Okay, minus 12 plus 2 plus 10, 0. See, it works. So if you do get asked to solve a quadratic with complex coefficients, we can just use the quad formula. The one step you need to be aware of is that, if you've got a square root of some complex number, let it equal a plus bi. That's how you square root complex numbers. It's a simple way of square rooting it. The really crafty way of square rooting a complex number, particularly if it's got magnitude 1, like square root of I, there's actually a really quick way to do that, because if you think about it, on a on the Argand diagram, if you're there at I, the square root of that would be halfway, because you just have to half the argument, and so you can see it's 1 over root 2 plus 1 over root 2i, or e to the I pi over 2, because the modulus is going to be 1 and the argument's going to be pi over 2. But there we go. Anyway, hope you enjoyed the video, hope it was useful. Keep up the good work. Bye bye.